Hi, let's continue with our exam revision. So let's move on to measurement. Calculate the area of the following. So have a go first. Okay, so they're asking us to calculate the area. So just to recap, when we calculate area, we are breaking up the area into smaller squares, which is why we write our final units with a square. So over here, I can see it's almost a rectangle. If I had a complete line here, I'd have a rectangle, but there's been a part of it cut out. Now that part looks like a square because I can see all these sides here are equal. We know these lines mean that they're equal. So I need to work out, well, if I went 9 times 6, so the area of the rectangle is length times width. Area is 9 times 6. So the area would be 54 centimeters squared. That will be fine, but the problem is this part has been cut out. So I've got to work out that part there, that square, and subtract it from the total area of that rectangle. To do that, I need to work out are these lengths here that are all equal. Now, to work those out, I have to use the information given. And I can see this long line here is 9 centimeters, which means this length, I'll change my color. So this length here plus that length here and that length down there, if I put those three lines together, it'll give me the length of 9 centimeters. Now, there are those lines are 3 lines or 3 parts. And because they are all equal, to work out the length of one, well, what's 9 divided by 3? 9 divided by 3 parts, yep, is just 3. So each one of these is 3 centimeters. So I'll put that in there. 3, 6, 9, yep, they all add up to 9 centimeters. And now that I know that they are all 3 centimeters, to work out, in this case, it's a square that's being cut out. Once again, the area of a square is like length times width or length times length because the lengths are equal. 3 times 3 is just 9 centimeters squared. So that part that's being cut out is 9 centimeters squared. So the total area or the area of this shape is equal to 54, take away 9, which will leave me with 45 centimeters squared. So that would be the area. Okay, our next shape is a trapezium. So when finding areas of different shapes, you have to be able to identify the shape. Always write the formula for that shape. So for a trapezium, the area A is equal to half A plus B and then times H. You can just write H or you can write times H if that helps. And we also know there's a times in between the half and the brackets. You have to know which one's which. So A and B are the 2 parallel lines, so the ones that are on top and bottom in this case. So I can say A is going to be my 3, B can be my 11. And it doesn't really matter which one's which. Now, H is height. Height has to be at a 90-degree angle. So here's 90 degrees with the base. Okay, so that's my height of 5 millimeters. So H can equal 5. Always do that first so you know which variable is which. Now, substitute those values into our equation or formula. So A is equal to half. Now, I must do my brackets first, A plus B. So I'll just do a step now. A is 3, B is 11. So 3 plus 11 leaves me with 14. So times 14 and then times H, which is 5. So I did A plus B first. My next step is to just simplify. Now I know I've got a half here, and that 14 is really sitting on top. So 2 and 14 can simplify. 2 divided by 2 is 1. 14 divided by 2 is 7. So I'm left with 1 times 7 times 5, which is equal to 35 millimeters. Don't forget to write squared because we're dealing with area. Okay, our next questions involve finding the areas of circles. And if you read the question, it says, instead of putting pi into your calculator, they want you to use pi as a fraction here, 22 divided by 7. And the next one is asking you to use pi as 3.14. So you have to be able to work with fractions and also multiply with decimals. So if you have to revise those skills, please do so. Okay, so first of all, write the formula for calculating the area of a circle. Area is equal to pi r squared. That is something you should know by heart. Okay, so pi, I don't have a calculator, or they don't want me to use a calculator. I have to use this for my pi. If you put 22 divided by 7 into your calculator, you'll see a decimal that starts with 3 and then has point and so on. That looks quite similar to pi. It's not exactly pi because we know pi is irrational and it can never be turned into a fraction. But 22 divided by 7 is a fraction that's close to pi, so we can use that sometimes. So area is equal to, so replace pi with 22 divided by 7 times r is radius. Now this line here is half my diameter. It's not a full line, so that is my radius. So 7 and I square that. So now I just simplify this. I've got 1 7 on the bottom and 2 on top. If it helps, write 7 over 1 so you can see that more clearly. So cancel that one, one's gone, and that becomes just 1 7. So I'm left with 22 times 7, which leaves me with 154 meters squared. For our next circle, they want us to use pi when it is 3.14. So area of a circle, once again, is pi r squared. Area is equal to, pi is now going to be 3.14. Is that my radius? Yes, r is 10 because it's half my diameter. Always double check that. So times 10 squared. Now, for this one, I'm going to write 3.14 times 10 squared is 100. Now, I can set this up to work it out. For example, when multiplying with decimals, ignore the decimals. So we'll have 314 times 100. You work that out first and then go back and move the decimal places, in this case, 2 times, 1, 2. But because I'm timesing by 100, I don't need to do that. I know my decimal moves 1, 2 places to the right because I'm multiplying. So my answer will be 314 centimeters squared. Don't forget to write your units. Our next question is a problem-solving one. So have a go first and we'll do it together. With questions like this, sometimes it helps to draw a diagram, so always do that. Okay, so this is what I'm working with. I've drawn a triangle. It's telling me the height is 10, so there's my height parallel to the base, so my height is 10. Area is 50 centimeters squared, and they want me to find the base, B. So I can see clearly what I'm trying to do. Now, first, write the formula for a triangle. The area of a triangle is equal to base times height divided by 2. Or half base times height, same thing. Now, fill in what information we have. I know A is 50. So I'm going to write 50 equals. B is what I'm trying to find. So B stays there times my height, which is 10, and divided by 2. By doing that, all I have to do now is solve this equation. I'm going to rewrite this equation just so it's easier to work with. So I'm going to write, instead of writing B times 10 like that, I'm going to have this 50 equals 10B divided by 2. And I'm going to rewrite it so the B is on this side here. And now I can solve this nice and easily. Times by 2. So 10B equals 100. Divide by 10. So B will equal 100 divided by 10 is just 10. Our units are centimeters. Don't write squared. We haven't found the area. We already have the area. We found the length B on the bottom, which is 10 centimeters. So we can see how useful solving equations actually is. Our next couple of questions involve calculating the volume. So have a go first, and we'll just do some revision on what volume is. Okay, when it comes to volume, it's now dealing with 3D shapes. And we've learned how to calculate the volume of prisms. So volume is equal to, you see this A times H. Now it's important to understand what these two letters represent, or symbols represent. A is area of the cross section. And H usually stands for height, but it doesn't have to be height. It can be, I like to use distance. Sometimes in other examples, you see length. And I'll explain why all these different keywords mean the same thing. Now, you have to understand what we mean by cross-section as well. So if I have a look at this example here, I can see this shape here. It's an odd sort of shape, but they're telling us the area is 10 centimeters squared. The reason why they're telling us that area is that is the cross-section. Cross-section means if I can slice all the way through this shape to the bottom, do I end up with the exact same shape? Yes, I do. That's the cross-section. It's sort of like having a perfect cucumber. If you've got a perfect cucumber, so it's a perfect shape, and you slice all the way through, you see a circle all the way through, okay? And so this shape, if I slice it from top to bottom or bottom to top, I will have that shape over here. Okay, so they've actually done the first step for us. They've given us the area of the cross-section. So that's done. So it's 10 centimeters squared. Now, what's the height between them? Okay, that's where that h comes in, so height. Or I can say what's the distance between them or the length between them. So what's the distance or length or height between the top shape and that bottom shape? It's 3 centimeters. So once we have those two things, all we have to do is go area of cross section, which was 10, times that height of 3. So the volume is going to be 30, I think it was centimeters, and put a cube there. That cube means it's cubes. With 30 cubes make up the volume of that shape that we just found. Okay? And that's how we do volume. You've got to work out the cross section and then times it by the height or space between the two cross sections. So for a rectangular prism, I can see that I have more than one cross section. I can slice it from top to bottom, or from this side to the back, so front, back, or from this side to the other side. So there's more than one cross section with a rectangle. You just pick one and work with that. Okay, so for this one, I know that this length here is also 6 meters, and that one here is also 4 meters. Sometimes it helps to write down other measurements as well. And that here is also 2 meters, because with a rectangular prism, those are going to be equal. So if I found the area of the cross section for the top part and go down all the way, and then to that cross section here, we'll go all the way to the bottom, I can use that one. So I might stick with that. So the area of this top rectangle, if I drew it separately, I'm dealing with this. I've got 6 times 2. So that area is going to be 8 meters squared. So the area of the top part. I've got that. So volume is going to be 8 meters squared. That's the area of the cross section times, what's the space between the top and the bottom? It is 2 meters. I can see that. So times it by 2. So V is equal to 8 times 2, which is just going to be 16 meters cubed. And that's the volume for that rectangular prism. Sometimes you see this. You see them going 6 times 2, or 6 times 4 in this case, times 2. That's what we're actually doing. That's the area of the rectangle, and then times it by the height or the space between them. Okay, our next question relates to some statistics, and it says to place the following bar graph, so the information here, into the following frequency table. Okay, so for this one, we're going to interpret what we have here. So our categories are almonds, cashew nuts, walnuts, and peanuts, and the number of students that like each of those. So frequency is the number of students in this case that like almonds. So it's approximately 5 students. Cashew nuts looks like it's 8. Walnuts, approximately 3. Peanuts, we've got 10. That's our frequency. Relative frequency is an important keyword, and that just means write the frequency as a fraction of the total. So the total I've got here, I've got to work that out first, is adding up all these here. So that leaves me with a total of 26, if I add those up. So the relative frequency would be, how many students like almonds? Well, we've got 5 out of 26, and we're done. Write it as a fraction. Here, we've got 8 out of 26. Here, we've got 3 out of 26. And peanuts, we have 10 out of 26. And that's done. And then the percentage frequency is to turn these fractions into a percentage. So you'd have 5 out of 26, and we know to turn anything into a percentage, you times it by 100 and get the answer. Same thing for here, 8 over 26 times 100 will give me my percentage. So you can work out the percentages and do that for the rest of this. Okay, our last 2 questions involve now probability and looking at Venn diagrams. So this question says, out of 50 students, 35 like maths, 15 like English. Out of 50 students, 35 like maths, 15 like English, and 5 like both. Then it asks us to put this information into a Venn diagram. Let's do that first. Now, when drawing a Venn diagram, your sample space is represented by a rectangle. So all the numbers that we're dealing with will go into that rectangle, and usually it's outside. We can have an S for sample space, and sample space means the total number of things we're dealing with. In this case, we have 50 students. So we're working with 50 students. So everything in that rectangle has to add up to 50. Next, we're dealing with 2, categories. We've got maths and we have English. So maths and English. Now, it doesn't matter if you did English first, that's fine as well. Now, it's important to always start with the middle first and then work your way on the outside. So it tells us that 35 like maths, yes, 15 like English, and 5 like both. So straight away, my 5 goes in the intersection, okay? Because they belong to both the maths and English, okay? So there's already 5 students in each of those. Now, I can't just put 35 here because in that circle that represents maths, I now have 40 students in there, 35 plus 5, and that's wrong. So 35 take away the 5 I've got already is 30. So that's 30 in that part there. And English, we see 15 like English. I've got 5 already, so 15 take away 5 leaves me with 10 more. So in that total circle for English, I've got 15 in there. So you can see why it was important to start with the middle. Now just be careful, we haven't finished yet. All our numbers must add up to that 50. So I've got so far 30 plus 10 is 40 and 40 plus 5 is 45. I don't have 50 yet. That means that the remainder, which is also 5, goes out there. That is telling us there are 5 students who don't like either. All these numbers add to 50, so it's accurate. The next question said, what's the probability? So that was A. B said, what's the probability of getting a student that likes both maths and English? So to do that, how many students like both maths and English? We can see it's 5. So probability is going to be equal to 5 out of the total. The base is always a total, which is 50. Always simplify your fractions. So 5 divided by 5 is 1. 50 divided by 5 is 10. Okay? So we have a 1 in 10 chance of picking someone who likes both. With our last question, it's asking us to, we've got a Venn diagram now, and it's asking us to find x. And we can see x is sitting in the middle just there. Okay, so to do this, once again, equations become very useful. To find x, which is our middle number, well, we know that all of these numbers in that rectangle, that sample space, have to add up to 32. So a way to do this is to just write an equation. I know that 8 plus the x plus the 13 plus 5 all add up to 32. There's an equation. I solve for x and I am done. I'll add up the numbers first, so simplify. So x plus, that will add up to 26. Sorry about that. It will add up to 26 equals 32. Subtract 26 on both sides and we end up with x being 6. So that middle number would have been 6 and all those numbers then add up to 32. Thank you.